Hello students, welcome to Marine Engineering Tutorials. I'm Atul Kumar Gupta and back with a new tutorial. Presently we are studying marine auxiliary systems and deck machinery. Today we have 20th lecture and the topics are uses of compressed air on ships, requirements for air receivers and compressors, constructional details of main and emergency air receivers, and effect of moisture and oil in compressed air systems. In this tutorial, we will first learn about the uses of compressed air on ships. Then we will learn about the requirements for air receivers and compressors. Next, we will learn about the constructional details of main and emergency air receivers. Lastly, we will learn about the effects of moisture and oil in compressed air systems. Let's discuss these through the following slides. Uses of compressed air on board. For starting, the diesel engine. Large diesel engines are started by compressed air which acts on the piston during the expansion stroke of cylinder and provides the turning moment. The starting air pressure should be between 15 to 30 bar. For use as service air. Compressed air at 7 bar is used as service air in the engine room for various purposes such as cleaning filters, charging hydrophore, cleaning boiler tubes, etc. For pneumatic control system. To use service air for pneumatic control system, it is first passed through the filters and dryer to remove dirt, oil and moisture. Pneumatic control system is especially useful in hazardous areas such as pump room and deck of tanker where combustible vapors may be present because air is a safe medium. For blowing soot in exhaust gas economizers. Some of the motor vessels use compressed air for blowing or removing the soot from the exhaust gas economizer for improving the heat transfer and preventing the soot fires. Compressed air is more effective than steam as it is available at higher pressure and is comparatively dry. For blowing sea chest gratings. Compressed air is also used for blowing sea chest gratings to remove the obstructions in way of seawater intake, which is used for cooling and miscellaneous purposes. For atomizing fuel in boilers and incinerators. Service air can be used for atomizing the fuel in steam jet and ultrasonic burners used in boilers when steam is not available and is also used in some incinerators. For remote operation of various systems. Compressed air is used for remote operation of various systems which may include propulsion engine, cargo hold bilge system valves, ballast system valves, buckling system valves, quick closing valves during fire, inert gas system valves, etc. for operation of ventilation dampers. Service air is used for the control of engine room ventilation dampers, which is very helpful in quickly sealing the engine room in case of fire. For operation of pneumatic pumps. Service air is used for operation of pneumatically operated pumps such as Wilden pump, used for containing the oil spills, testing fuel injectors of diesel engine, operation of hydraulic tensioning devices, etc. For blowing the whistle. Service air is used for blowing the whistle for alerting the ship's crew regarding emergencies or alerting nearby ships or boats. For breathing in enclosed spaces. Compressed air at 200 to 300 bar is used as breathing air in self-contained breathing apparatus, emergency escape breathing device, and in cylinders of enclosed lifeboats. For closing main engine exhaust valves. Compressed air is used as spring air for closing the hydraulically operated exhaust valves equipped on main engine. For operation of pneumatic machines. Service air is used for operation of pneumatic machines or tools on deck and engine room for chipping, grinding, grit blasting, spray painting, nut runner, impact wrench, drilling, etc. For hoisting, gangway, and lifeboat on tankers. Service air is used for hoisting the gangway and lifeboat on tankers due to hazardous environment on the deck. It is also used to operate small winches for mucking purpose during cargo tank cleaning operation. For gas freeing on tankers. Service air is used for operating the fan during gas freeing operation on tankers. For operation of explosion proof lights. Service air can be used to power the explosion proof light during cargo tank cleaning operation. Compressed air operates an air motor which in turn drives the dynamo to produce electricity and power the lamp. For emergency operation of steam winches. Service air can be used to operate steam-driven mooring winches when steam is not available during ship's dry docking. Requirements for air compressors and receivers. Air compressors used on the ships usually operate intermittently and keep the air receivers pressurized within specific limits. The air compressors and receivers equipped on ship are in accordance with solar and class requirements. For reliable and safe operation, air compressors and receivers require periodic maintenance and inspection. Number and capacity of main air compressors required. Two starting air compressors of sufficient capacity must be fitted to meet the engine requirements. Each compressor must be able to press up the air receiver from 15 bar to 25 bar in 30 minutes. Number and capacity of main air receivers required. Two air receivers with total capacity sufficient for 12 consecutive starts without refilling for reversible engines and 6 starts for non-reversible engines must be provided. Capacity of emergency air compressor and receiver required. Emergency air compressor should be independently driven either with diesel engine or with emergency generator and must be able to discharge the emergency air receiver within 30 minutes for at least 3 consecutive starts of diesel generator. Compressed air pressure for starting main and auxiliary engines. Main and auxiliary diesel engines on motor ships and auxiliary diesel engine on steamships require air pressure of 15 to 30 bar for their starting. Service and control air pressures. Service and control air at a pressure of 6 to 7 bar is required for ships, which is usually obtained from high pressure air through reducing valve or by an independent service and control air compressor. Preventing overpressures in air receivers. Relief valves are normally fitted to the air receivers, which prevent pressure rise above 10% of the working pressure. If the relief valve can be isolated from the receiver, then air receiver must be equipped with fusible plug having its melting point at 150 °C to release the air with full flow in case of engine room fire. Main air receiver. The sketch shows a main air receiver which may have horizontal or vertical layout and secured with mounting brackets on the ship. Air receiver is constructed with good quality low carbon steel having carbon 0.2%, silicon 0.35%, manganese 0.1%, sulfur 0.05%, phosphorus 0.05%, and having a ultimate tensile strength of 460 meganewton per meter square. Welding must be done to class 1 regulation, which should be radiographed. Annealing must be carried out at a temperature of about 600 °C, and test pieces must be provided for bend, impact, and tensile tests together with micrographic and macrographic examination. A pressure tapping is provided for connecting the pressure gauge and pressure switch, for monitoring the receiver's pressure, and for automatic start and stop of main air compressor. The filling valve must always be opened before starting the compressor. The air bottle is very efficient moisture separator, which should be periodically drained to prevent internal corrosion and pitting. Air to auxiliary engine is always kept open for automatic starting of the standby generator in case of blackout or when load increases. When separate service or control air compressor is not equipped on ship, this connection provides the same through a reducing valve. Before opening the main engine starting air, accumulated moisture should be thoroughly drained. After the maneuvering, starting air may be closed according to the system requirement. Air for the ship's horn is usually kept open always, as this is used for warning system. Manhole is used for internal inspection and maintenance to prevent internal corrosion. It is inspected annually and every 5 years by the classification surveyor. In the horizontal arrangement, manhole is placed on the disc end, whereas in vertical arrangement, manhole is placed on the cylindrical part with its minor axis in the longitudinal direction. Relief valve protects the air receiver against overpressurization. When its pressure reaches 10% above the normal storage pressure, operation of relief valve should be periodically tested. Fusible plug drains the air if its temperature reaches 150 degrees Celsius in the case of engine room fire. Emergency air receiver. The sketch shows an emergency air receiver which is usually installed vertically. In comparison to the main air receiver, it has only a few mountings as it serves the purpose of first start arrangement, which means that it helps to start the generator when there is no power available on the ship. Compressed air from emergency air compressor is admitted to the receiver through the inlet valve mounted on the top. The drain valve is equipped at the bottom to drain away the separated condensate. The receiver's inlet and outlet connections should be widely separated, which helps in moisture separation. The air outlet can have two arrangements as shown in the sketch. In both arrangements, the inlet and outlet connections are separated wide apart by using an inlet pipe within the receiver. The outlet to generator engines is also interconnected with main air receivers. An elliptical manhole is provided on the cylindrical part for internal inspection and maintenance to prevent internal corrosion. The relief valve protects the receivers against overpressurization. The fusible plug prevents explosion of receiver during engine room fire. Effect of moisture in air and its removal. Effect of moisture in compressed air system. Moisture is always present in air and it corrodes the compressed air system. In pneumatic control systems, moisture is highly undesirable as it causes corrosion and blockages. Amount of moisture present in air. Saturated air at atmospheric pressure and 25 degrees Celsius holds approximately 23 grams of water per cubic meter of air. Capacity of air to hold moisture is dependent on its temperature. That is, higher the air temperature, greater is its capacity to hold moisture. Every 15 degrees Celsius increase in air temperature doubles its water holding capacity. Principle used for removal of moisture. To remove the moisture from air, temperature of air must be brought down below its saturation temperature such that free moisture is condensed. Methods of moisture removal in compressors. To remove the moisture from air, temperature of air must be brought down below its saturation temperature such that the free moisture is condensed. Air compressors used on the ship are multi-stage with inter and after coolers. When the air is cooled between the stages, water associated with air is separated. It should be periodically drained from inter and after coolers, manually or automatically by the air drain trap. During the storage of air, moisture is further separated, which should be removed periodically. Types of dryers in use. For pneumatic control system, air is further dried, usually in refrigeration type dryer, where it is cooled to 5 degrees Celsius and the moisture content is reduced to approximately 4 grams per cubic meter, which is acceptable. Occasionally, absorption type dryer equipped in pair may be used where moisture is absorbed by activated alumina during absorption cycle and dissolved in regeneration cycle. Effect of oil in air and its removal. How the oil enters in compressed air. Lubricating oil is used for cylinder lubrication, which is an essential requirement for proper functioning of reciprocating air compressors. During the compression stroke, oily vapors are carried away along with the compressed air, which gets condensed in the air receivers. What is the effect of oil in compressed air systems? In starting air system, the oil associated with air gets deposited in the starting air pipe and acts as combustible material. It can cause explosion of the starting air pipe if the air starting valve remains stuck open and provides source of heat for the explosion. In pneumatic control system, oil can degrade the seal and O-rings, resulting in leaks and failures. Oil can block filters and pipes, thus reducing the airflow. Oil can cause sticky residues in valves and affect the response time. How to eliminate oil from compressed air systems? Cylindrical lubrication should be kept minimum to prevent the dangers associated with it in the compressed air systems. Oil should be frequently removed from air receivers by draining it along with the condensate. For pneumatic control system, compressed air is passed through oil absorption or coalescing filter to remove oil. Sometimes oil-free compressors are used for pneumatic control system where Teflon piston rings are used which have self-lubricating properties. This completes the study of uses of compressed air on ships, requirements for air receivers and compressors, constructional details of main and emergency air receivers, and effect of moisture and oil in compressed air systems. This book is written by me and covers all the topics as per the syllabus specified by Indian Maritime University. It clarifies the concept with simple illustrations. The book also provides answers to all the questions which have appeared in the examination conducted by Indian Maritime University. The book can help the students in preparing for the exam and also to work on ships' auxiliary systems and deck machinery safely. Hope that you have liked the lecture. You can write your feedback in the comment box. If you have liked the tutorial, you may share it with your friends. You may subscribe to the channel for getting notification about the new tutorials. I will be back with the new lecture shortly. Thanks for watching till the end.